In this lesson, we'll talk about compound statements and connectives. First, we'll take a look at some simple statements. A simple statement expresses one idea. Some examples are, I am tired. I exercise 3 times per week. I am in good health. I have lots of energy. Each of these statements expresses a single independent idea. Now we'll talk about compound statements. Compound statements combine 2 or more simple statements by using words that are called connectives. Therefore, compound statements convey more than one idea. Here are some examples of connectives. The words and, or, if, and the phrase if and only if. Now, using these connectives, we can now look at some examples of some compound statements. I am tired and I exercise every day. I exercise 3 times per week, or I am tired. I am tired if I exercise every day. I have lots of energy if and only if I exercise every day. These are all examples of compound statements, and they use the connectives and, or if and only if. So let's look at some symbolic representations of these connectives. So using some of the statements we saw before, the symbol for and is, as shown here. It looks a little bit like an A, but there's no crossbar, and you might remember it since it kind of looks like an A, and the word and begins with the word A. The symbol for or is this symbol turned upside down. So now we can take our verbal compound statements and translate these into symbols. We've assigned a letter name for each of the simple statements. Here's a compound statement. I am tired and I exercise 3 times per week. Since this is an and statement, we insert the symbol for and between the names of the statements P and Q. This statement means P and Q, and a compound statement containing the word and is called a conjunction. I exercise 3 times per week, or I am tired. We have statements Q and P here, and this is an or statement, so we insert the symbol for or, and this compound statement containing or is called a disjunction. Now we need to look at this word or a little bit more. In verbal compound statements, the connective or can really mean 2 different things. So here we have 2 simple statements, P and Q. P is you may choose a salad. Q, you may choose a soup. The menu in a restaurant says you may choose a salad or you may choose a soup. Now symbolically, we would write the statement with the symbol for or, and we know that when we go in a restaurant and we see this option, this means that we can choose a salad or a soup, but not both. So this use of or excludes one of the options. It's either P or Q. However, there are statements where or is inclusive. Statement P, I like chocolate. Statement Q, I like vanilla. Compound statement, I like chocolate or vanilla. This means the same thing as I like chocolate or I like vanilla. Now we might consider this an example of inclusive or. However, the inclusive or is still written with the symbol for or. So in mathematics, we have to come to an agreement about the symbol or. Since both statements are written with the symbol for or, we're going to always assume that the or is inclusive. So when we see disjunctions or statements in our logic exercises, we're going to assume that the or statement means P or Q or both. Now we want to look at translating disjunctions and conjunctions, that is or statements and statements, from a symbolic form into a verbal form. So here I have a variety of simple statements, and I've been given a compound statement, Q or P. So my verbal translation of Q or P would be, I exercise 3 times per week, or I am tired. This is Q or P. We can also go from the verbal form to the symbolic form. I have lots of energy and I am not tired. Symbolically, this is written T and not P, keeping in mind that the tilde symbol is used to indicate the negation of the simple statement I am tired, which would be I am not tired. Now there are other compound statements that we mentioned besides and or, and these are compound statements formed with the connectives if and only if. The if statement is called a conditional statement and is commonly written verbally in the if-then form. So we might have a compound statement such as, if I am running late, then I will call you. Now, these are two simple statements that are connected to form a compound statement. The simple statements being, I am running late and I will call you. Connected with the if-then, we have, if I am running late, then I will call you. Sometimes verbally we get a little bit lazy and we say, if I'm running late, I will call you. But that's really an if-then kind of scenario. So I'm running late, I will call you, and the if-then statement is written symbolically, in this case, with P, right arrow, Q. This means if P, then Q. So let's talk a little bit more about these conditional if-then statements. In an if-then statement, the statement before the connective is called the antecedent. Also, in an if-then statement, the statement after the connective is called the consequent. So we have a simple statement S, it is raining, and a simple statement T, I will bring an umbrella. We can have the conditional statement, if it is raining, then I will bring an umbrella. The antecedent is the first simple statement, it is raining. The consequent is the second simple statement, I will bring an umbrella. And this is a conditional statement because of the if-then that we see here. If it is raining, then I will bring an umbrella. And in symbol form, we write S, right arrow T, and this means if S, then T. Here's another. It is raining, I have an umbrella. We'll write in symbols. If I do not have an umbrella, then it is not raining. So this is an if-then statement, and we've got some negations here. Do not have an umbrella would be the negation of statement T. It is not raining is the negation of statement S. Since we have an if-then, we write, if not T, then not S. So that's tilde T, right arrow, tilde S. Now I want to throw a little math example in here. And before we do that, I want to give you a little background on a geometric concept called a polygon. A polygon is simply a shape composed of straight line segments joined at the ends, and you've seen many polygons and know them. These are shapes like triangles and quadrilaterals and pentagons, hexagons, etc. So notice in each of these shapes, their edges or their sides are straight lines, and they always join at the ends of those straight edges. Now the name of the polygon depends on the number of sides. Tri meaning 3, we have a triangle. Quad meaning 4, we have a quadrilateral. Pent means 5, pentagon, and so on. So let's talk a little bit about quadrilaterals. We saw in the previous figure that a polygon with 4 sides is called a quadrilateral. Now there are different kinds of quadrilaterals, and here are some examples of some common quadrilaterals. We have squares and trapezoids and parallelograms and rectangles. These are all 4-sided shapes, but they're all slightly different. They're all polygons because their edges are straight lines. They're all quadrilaterals because they have 4 sides. So let's just take a look at some if-thens, and because we know some things about polygons and quadrilaterals, we can determine whether these if-then statements are true. However, that's not the real goal of what we're doing right now. We're not really trying to determine if something is true or false yet. We're just looking at how to write these if-then statements. So our first simple statement S is the shape is a square. Our second simple statement T, the shape is a quadrilateral. We're going to form a conditional statement using if-then. So if S, then T. If the shape is a square, then the shape is a quadrilateral. And it just so happens that this happens to be a true statement. Again, we're not so worried at this point about the truthfulness or the falseness of this statement. We're really concerned about how to write the statement in symbols. So if S, then T is written S, right arrow T, and it means if the shape is a square, then the shape is a quadrilateral. Now, some conditional statements are not true if reversed. So here's a conditional simple statement. The shape is a square. The shape is a quadrilateral. We saw in the previous example that if the shape is a square, then the shape is a quadrilateral. Happened to be true. And here we have a conditional statement. If T, then S. If the shape is a quadrilateral, then the shape is a square. Now, we happen to know, because we know about quadrilaterals and squares, that this is not true, because there are other kinds of quadrilaterals besides squares. So you can't say that this is a truthful statement based on what we know to be true, that if the shape is a quadrilateral, then the shape is a square, because that shape could also be, as we saw, a rectangle, a quadrilateral, or a rhombus. Again, I'm bringing in some evaluation of whether the statements are true or false, just so you can kind of get the feel for where we're going. However, what's really important here is to understand how to write these if-then statements. So now we want to talk just a little bit more about conditional statements so that we can eventually get to a statement called a biconditional statement. Here's a simple statement, S. The shape is a polygon. A simple statement T. The sides of the shape are line segments connected at the ends. This symbolic statement, if S then T, can be translated to a verbal statement. If the shape is a polygon, then the sides of the shape are line segments connected at the ends. This conditional statement, if T then S, can be translated verbally to, if the sides of the shape or line segments connected at the ends, then the shape is a polygon. Now, this just so happens to be a conditional statement that can be written in either order. So we're going to now look at this as what we call a biconditional statement, and this is a statement that uses the if and only if phrase. Simple statement S, the shape is a polygon. Simple statement T, the sides of the shape are line segments connected at the ends. The shape is a polygon if and only if the sides of the shape are line segments connected at the ends. Now this sort of goes back to those other conditional statements we looked at that were true in both directions. So we can write this as S if and only if T. And so it's a biconditional statement, and the arrow is going in both directions. Now, a lot of the biconditional statements you'll be looking at and practicing with may or may not be true statements, but I wanted to show you one that was a true statement so you could get the idea of how a biconditional statement is used. So let's do a few more translations of these conditional and biconditional statements. Let's go from verbal to symbolic. Simple statement P, I am tired. Simple statement Q, I exercise 3 times per week. Simple statement S, I am in good health. Simple statement T, I have lots of energy. So let's look at a few more translation examples of these conditional and biconditional statements. That is, simple statements connected with the word if or with the words if and only if. Here are our simple statements we'll work with. P, I am tired. Q, I exercise 3 times per week. S, I am in good health. T, I have lots of energy. So here's a table, and we're going to complete the translation for the first one, which is if not Q, then not T. Remember that the arrow is an if-then statement. If the first statement, then the second statement. And in this case, it's the negation of Q and the negation of T. Since Q is I exercise 3 times per week, its negation would be I don't exercise 3 times per week. And since T is I have lots of energy, its negation would be I do not have lots of energy. So if I don't exercise 3 times per week, then I do not have lots of energy, would be our translation. Now in our second translation, we've been given the verbal statement and we want to write the symbolic form. I have lots of energy if and only if I am in good health. I have lots of energy is simple statement T. I am in good health is statement S. So we've got T and S, and we've got the words if and only if. That means the symbolic form of this statement would be T if and only if S. Last example. Another biconditional statement. Notice the if and only if symbol there. Not P if and only if T. Not P would be I am not tired. T is I have lots of energy. These symbols would be translated into a verbal statement. I am not tired if and only if I have lots of energy. So now we're going to look at some more compound statements, and this time they're going to involve parentheses. So I have several simple statements listed here, and I want to look at the translation of this set of symbols. Negation symbol, parentheses, Q and T. The verbal translation for this would be It is not true that I exercise 3 times per week and I have lots of energy. It is not true, that's the negation symbol, that I exercise 3 times per week and I have lots of energy. That's the compound statement that you see in the parentheses. Here's a verbal form. It is not true that I am in good health or that I am tired. Negation symbol, parentheses. It is not true, it's the negation symbol. I am in good health or that I am tired is Q or T. So when you have that negation symbol in parentheses, you will see these statements beginning with the words, it is not true. Now we've got to talk about the dominance of connectives, and this sounds very complicated, but I want you to sort of think of this like order of operations when you were doing algebraic expressions and you had to decide what went first. If a compound statement written with more than 2 simple statements is expressed in symbolic form and no parentheses are present, you must know how to group the statements. And there is a prescribed grouping order called the dominance of connectives, which says that the grouping of statements must occur in this order, given here as the most dominant to the least dominant. So biconditionals, that's the if and only if conditionals, are the most dominant. Then conditionals, that's the if-then statements. Conjunctions and disjunctions are equally dominant, sort of like in the order of operations addition and subtraction are. Well, that's your and statements and your or statements. And then your negations will come in as the last dominant thing. Now, statements before or after the most dominant connective should be grouped together, and we use parentheses to indicate the grouping. Statements before or after the most dominant connective are grouped together with parentheses. So as a reminder, I've noted at the top that the dominance order is biconditionals, most dominant, then conditionals, conjunctions and disjunctions equally dominant, and negations. Some simple statements. P, the weather is nice. Q, I drive to work. T, I walk to work. First, we're going to place the parentheses where needed according to the dominance of connective rules, and then we'll translate. So notice we've got 3 statements here, but we haven't been given what should be grouped together. So we have to use our rules for the dominance of the connectives in order to determine what gets grouped together. Now, the if-then is dominant to the or, because remember, the conditional is more dominant than the disjunction. That means that the statements appearing after the most dominant connective are grouped together. Since the most dominant connective is the if-then, the statements occurring after that, T or not Q, are grouped together. Now we can translate this. If the weather is nice, then I walk to work or I don't drive to work. So let's translate another, and let's think about our order and our dominance of connectives. Here are 3 simple statements. P, the test is hard. Q, I study effectively. S, I will pass the test. Here's a compound statement. I will not pass the test if and only if the test is hard or I do not study effectively. We have 2 connectives here because we have 3 simple statements. Our connectives are if and only if and the word or. I will not pass the test is the negation of S. If and only if, the double arrow symbol. The test is hard, statement P. Or, I do not study effectively, the negation of Q. So, because this sentence has no commas in it, and the statement has no parentheses, we would have to follow the dominance of connectives to really write this the proper way. Since the most dominant connective is the biconditional if and only if, those statements appearing after that biconditional are grouped together with parentheses. That is the or part of this overall compound statement. I will not pass the test if and only if the test is hard, or I do not study effectively. Now this is slightly different from what you see here because there's a comma in this statement. Symbolically, we would have to write those statements that are on the same side of the comma grouped together. I will not pass the test is the negation of S. If and only if is the double arrow. The test is hard is P. Or I do not study effectively, the tilde Q. Because not passing the test and the test being hard are on the same side, that biconditional if and only if statement is grouped together with parentheses when we write it symbolically. So this comma is what tells us to do. So if the comma appears in the statement, we don't have to worry about figuring out where the parentheses go. We don't apply those rules for dominance of connectives. The comma tells us what has to be grouped together, and those statements on the same side of the comma would be grouped together in our translation. So we'll do one more here, and I've got our reminder here about what's most dominant and what has to be grouped together in order of most dominant to least dominant. 3 statements. A verbal statement that we're going to translate to symbols. If the test is hard and I don't study a lot, then I will not pass the test. So we notice that our connectives are the if-then conditional and the conjunction and. So we notice that statement P, the connective and the negation of Q are on the same side of the comma, meaning they're going to be contained in parentheses in our translated statement. So here's what we have. If P and not Q, then not S. The comma told us to put the P and not Q in the parentheses together. So let's make sure this is right. We've got statement P, the test is hard. We've got statement Q, I've studied a lot, so the negation is I don't study a lot or I did not study a lot. We've got statement S, I will pass the test. The negation is I will not pass the test. We've got P and not Q. Test is hard and I don't study. We've also got if then. So if the test is hard and I don't study a lot, grouped together because of the comma, then I will not pass the test. That's the negation of S.